Hello, welcome to Mr. Jensen's math class. Today we're going to look at what are called the special right triangles. There are two special right triangles. One of them is the 30, 60, 90 degree right triangle, and the other is a 45, 45, 90 degree right triangle. Okay, this is just going to be a short video talking about the ratios that we see all the time with these two special right triangles that are used an awful lot in trigonometry. Okay, so I'm going to do my best to draw triangles in a way that are going to be understood that they are triangles. But I'm going to start by looking at the 30, 60, 90 and a little bit about where does that triangle come from. I trust that you all know something about the equilateral triangle. In an equilateral triangle, all three sides are going to be equal, and all three angles, therefore, will also be equal. Since the angles all add up to 180 degrees, and each angle is the same, 3 times each angle would be 180 degrees, each angle, therefore, is 60 degrees. So this angle up at the top is 60 degrees, this angle at the bottom right is 60 degrees, and the angle down here at the bottom left is 60 degrees. Okay. Also, I'm just going to choose a particular value for the sides because these sides, this side might be 10, it might be 12, it could be whatever it is. The three sides are going to be the same. Okay. So we start with an equilateral triangle, and you say, why are you looking at an equilateral triangle if you're going to talk about the 30, 60, 90? Well, the reason I want to do that is suppose that we were going to drop a segment, it's called an altitude, from the top of this equilateral triangle down to the bottom or the base of the equilateral triangle. And we're going to do that in such a way that we create a right angle there. If this angle on the right is 90 degrees, then this angle on the left of the altitude is also 90 degrees. From our properties of proving triangles congruent, we know that if we've got an angle and another angle and a side that are congruent to each other, okay, so this angle is 90 degrees, this angle is 60 degrees, and this side is 10, we know that these two triangles have to be equal to each other. Well, what that tells me is that each of these angles up here, the side to the left, the side to the right is 30 degrees, and the side to the right is 30 degrees. So we have a 30, 60, 90 degree right triangle. The other thing you'll notice is since the triangle got cut in half, this bottom piece that was 10 has been cut in half. And so this piece to the right is 5, and this piece to the left is 5. Okay. So now I'm going to slide down just a little bit, and we're going to consider just this triangle that's on the right-hand side. And what you'll notice about that triangle is that it is a 30, 60, 90 degree right triangle. Now, in the triangle above, I said, suppose the hypotenuse is 10, therefore the short leg is 5 because that's half of it. That's true in every single 30, 60, 90 degree right triangle. The short leg, which is the side opposite the smaller angle, is half the length of the hypotenuse. So what I want to do is instead of calling this side 5 and this side 10, if the short leg is x, the hypotenuse would be 2x. So hypothetically, I know that this side is 6. I would know that 2x is 12. If I'm given that the hypotenuse is 8, I know the short leg is 4. Okay, the hypotenuse is always twice as long as the short leg, and that's because the altitude here, remember the altitude cut that 30, 60, 90 in half. So the short leg is half of the side that was equal to the hypotenuse. So a question that we're going to need to explore, though, is what is the length of the long leg. So I'm going to call that value h for height. I'm going to use my Pythagorean theorem, h squared plus x squared equals 2x squared. Remember that the Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. So I've got the leg h squared, the leg x squared, and the hypotenuse 2x squared. So h squared plus x squared will equal 4x squared. Remember, the 2 is getting squared and the x is also getting squared. Now, moving forward algebraically, I'm going to subtract x squared from both sides, and h squared will equal 3x squared. 4x squared minus 1x squared is 3x squared. The next step will be to take the square root of both sides. And if I'm taking the square root of 3x squared, that's the same as the square root of 3 times the square root of the x squared. The square root of 3 is messy. I'm going to leave that the square root of 3, but the square root of x squared is going to equal x. What number times itself is x times x? That number would be x. So the square root of h squared is h equals x times the square root of 3. So this hypotenuse, the long leg, will be, oops, didn't need to do that. The hypotenuse will be x root 3. So what that tells me is, again, suppose my short leg is 7. My hypotenuse would be 14. My long leg there then will be 7 times the square root of 3. And that will play out, and I just picked 7 for the short leg, that would play out regardless of what values we're given, we have, or we know. Okay, so suppose we continue with that knowledge. I'm going to make a clean picture here. That we have a 30, 60, 90-degree right triangle. If the short leg is 6, the hypotenuse will be 12, and the long leg will be 6 times the square root of 3. Because remember our pattern. If the short leg is x, the hypotenuse is 2x, and the long leg is x times the square root of 3. I'm just going to use this picture. I'm going to erase and rewrite rather than redrawing a picture every time. If my hypotenuse is 20, my short leg is going to be 10, because that's going to be 20 divided by 2 is the 10, and the long leg is going to be 10 times the square root of 3, because remember, it's x times the square root of 3 for the long leg. Where things get a little bit more confusing is if maybe like this. What if the hypotenuse is 15? Remember, the short leg down here is half the length of the hypotenuse. I'm good with 15 halves. If you want to call that 7.5, you can. I'm going to leave it half of 15. My long leg then is going to be 15 halves, or half of 15 times the square root of 3. Should not be too challenging. A couple more examples here. If my long leg is 8 times the square root of 3, the short leg is going to be 8, because the relationship between the long leg and the short leg is that the long leg is the same length as the short leg times the square root of 3. And when I look at this 8 root 3, and a lot of people call that 8 root 3, I choose to call it 8 times the square root of 3. So to go from 8 times the square root of 3 down to the 8, the long leg is 8 times the square root of 3. I would divide that by the square root of 3, and the short leg is 8. The hypotenuse then will be 16, because the hypotenuse is the short leg times 2, which is 16. And a lot of times we're comfortable with, what if the long leg is 8 times root 3 or 10 times root 3 or 7 times root 3? Let's suppose, though, that our long leg is 10. If x root 3, the long leg, equals 10, how would we find x, the short leg? Well, to get the x by itself, you would need to divide both sides by root 3, and x will equal 10 divided by the square root of 3. There's controversy today. The is it okay if I leave the radical in the denominator? Can I change it? Personally, I have mixed feelings. I'm just going to go through and rationalize my denominator so that that gets reinforced as a skill. That means I really want to multiply the numerator and the denominator both by the square root of 3, because 10 times the square root of 3 gives me a numerator of 10 root 3, but root 3 times root 3 gives me a denominator of 3. So if x root 3, the long leg, is 10, the short leg is 10 root 3 divided by 3. The hypotenuse, remember, is twice the short leg. So I'm going to multiply the 10 root 3 over 3 times 2 to find the length of the hypotenuse, and that's simply 20 root 3 over 3. Okay, so that gives us a quick look at the 30, 60, 90 degree right triangle. Let's go back up and look at the 45, 45, 90 degree right triangle. If you recall, with the 30, 60, 90, we started by looking at the equilateral triangle and looked at those relationships. For the 45, 45, 90, what I'm going to start by looking at, actually, is a square. And you'll recall in a square that all of the sides are equal. So if this side is x, this side would be x, x, and x. Or if one side's 10, they're all 10. If one side's 8, they're all 8. I'm going to use x. And in a square, the angles are all 90 degrees. Of course, what I want to do here, just like the 30, 60, 90, we cut it in half. With the 45, 45, 90, I'm going to cut the square in half. And I'm only going to focus on this piece of the square. So the question is, what is the length of the hypotenuse? Of course, before we get there, each of these angles, what's the measure of this angle here, and what's the measure of this angle here? Hopefully you'll recall that in triangles, if two sides are equal, the angles opposite them will be equal. So these two angles that we're looking for, here and here, they're the same and they add up to 90 degrees. Therefore, they must both be 45 degrees. Okay, so this is where we create our 45, 45, 90 degree right triangle. I'm going to, rather than try to do more on that picture, let's come down just a little bit. Whoops, I don't want to do that. Let's just draw the triangle. And we have a 45, 45, 90 degree right triangle. Remember, in a 45, 45, 90, we said if this side, if the short leg is x, actually we don't have a short leg and a long leg. The two legs are the same length. Again, remember that in a right triangle, leg squared plus leg squared equals hypotenuse squared. So I know the length of the two legs. And the reason I like to do this is reflect back to the equilateral. Just because, or the 30, 60, 90, because it came from the equilateral, we knew the hypotenuse was 2x and the short leg was x. We used our Pythagorean theorem to find the third side. Same thing here. Because we know the 45, 45, 90 came from the square, we know that the two legs are both x. To find our hypotenuse, which again I'm going to call h, we're going to use the Pythagorean theorem again. So you recall that leg squared plus leg squared equals hypotenuse squared. The two legs are each x, so x squared plus x squared equals h squared. So h squared is equal to 1x squared plus another x squared. That would be 2x squared. And solving the rest of this equation for h is similar to what we did earlier. Now when I take the square root of both sides, recall that because I have 2 times x squared, the square root of 2x squared is the same as the square root of 2 times the square root of x squared. We've already mentioned that the square root of x squared is x, and the square root of h squared is h. So we have h is equal to x times the square root of 2. So the hypotenuse here is always going to be x root 2. How is this going to play out? So again, consider, I'm going to push this down a little bit more. Consider we have a 45, 90-degree right triangle. And if one leg is x, the other leg is x, the hypotenuse is x times the square root of 2. So if this leg is 5, the other leg is 5, and the hypotenuse is 5 times the square root of 2. I hope that makes sense. Where this becomes a little bit more challenging, like with the 30, 60, 90 is, what if the hypotenuse is 7 root 2? Well, if x root 2 equals 7 root 2, I'm going to divide the square root of 2 from both sides, and x would equal 7. And that would be the same for both of those legs. They're each 7. That's not as difficult as this next situation. So suppose the hypotenuse is 10. Now in this case, instead of having x root 2 equals 7 root 2, what we have is x root 2, the hypotenuse, is equal to 10. So I'm going to divide both sides by the square root of 2, and x is equal to 10 divided by the square root of 2. Just like with the 30, 60, 90, when we had 10 over root 3, we rationalized the denominator. I'm going to do the same thing here. Multiply top and bottom both by the square root of 2. So 10 times the square root of 2 over root 2 times root 2, that's 2. Now you'll notice with the 30, 60, 90, 10 root 3 over 3, we stopped. But with 10 root 2 over 2, I'm not going to stop. And that's because 10 divided by 2 is divisible. 2 goes into 10 5 times. 10 divided by 2 is 5. So I have 5 times the square root of 2. So my short leg is 5 root 2. My hypotenuse is 10. One leg is 5 root 2. The other leg is also 5 root 2. Okay, so that's a quick look at the two special right triangles. Remember that the special right triangles are the 30, 60, 90 and 45, 45, 90-degree triangles. And honestly, moving forward into trig, an awful lot of the thinking and processing that we use is based off of these two triangles. So I would suggest that you practice these, get good at them. If this video is helpful for you, please subscribe, like, and tell your friends. Thank you.